Topic 4-6, Factoring Revisited. I don't have the actual note pages with me, and I'll just be working these on a blank sheet of paper, but you'll be able to follow along with your notes. So number 1 says to factor x squared minus 7x plus 12. Now, if we were to use our sums and products approach, we would sum to the middle term, which is in terms of x, which in this case is negative 7x. And it would be a product of 12x squared because we took 12x and multiplied, or 12 and multiplied it by x squared. So, if we were to set this up in our box, we could go ahead and fill in the terms we know. In this case, we know the x squared and the 12. We want to take this negative 7x and form it into two factors that multiply out to 12x squared. Well, in this case, I can think of, since it's a positive product and a negative sum, they both need to be negative, so I can think of negative 3x and negative 4x. If you were to take negative 3x and negative 4x multiplied, you get negative 12x squared. Same sign, so add, keep the sign. 3 plus 4 is 7, negative 7, since they're both negative. So we'll go ahead and fill in the negative 3x, the negative 4x. And then from here, x times x gives us the x squared. X times negative 4, negative 4x. X times negative 3, negative 3x. If you notice, I'm taking this coefficient and moving it out. This only works when we have a coefficient of 1 on the x squared, and then our 12. So, in this case, the factors form of x squared minus 7x plus 12 would be x minus 4 times x minus 3. So far, so good. The next set of problems, we're going to try to think outside of the box. Like, quite literally. We're going to try to not necessarily move away from factoring with the box method, but you should be getting to the point where ones with factors, or excuse me, when we have expressions with a coefficient of 1 on our leading term, which is usually our x squared term, you should just be able to do a lot of these mentally at this point, finding the factors in your head. So we've got x squared minus x minus 30. So go ahead and you can just, we'll put our equal sign to, and we can open up a set of parentheses. In this case, since our coefficient is 1, we'll know that x times x gives us an x squared. So we can write the x and the x. So far so good. Now we need to think of two factors of 30, which would have, in this case, since it's negative 30, a difference of negative 1, since this negative x has a coefficient of negative 1. So, in this case, factors of 30 that have a difference of 1 are 5 and 6. And I want a negative 1, so the larger expression, or the larger number should be negative, so in this case negative 6. So if I were to place an x minus 6 and an x plus 5, you would check x times x is x squared. You can check this through our distributive property, x times x is x squared. Then we've got x times 5 is 5x, x times negative 6, negative 6x, and then negative 6 times positive 5 is a negative 30. If you were to combine these like terms, you would get negative x, which gives us our original product of x squared minus x minus 30, original expression. And there we go. For number 3, it says m squared minus 9m plus 20. So again, you can open up your parentheses, and m times n will give us the m squared we need. After that, since this is a positive 20, a positive c term, we need to think of two factors that will add up to negative 9. So in this case, both of them need to be negative. Two factors of 20 that I can think of are negative 4 and negative 5. They would make a positive 20 and add up to a negative 9, so we can go ahead and write the negative 4 and the negative 5. And again, if you were to use the distributive property to multiply this out, or the box method, whichever you prefer, we would see that we would get the m squared minus 9m plus 20. Moving on, let's look at number 4. In this case, it's a b squared plus 9b plus 14. Again, a leading coefficient of 1, since in our b squared, which is the term with the highest degree, a b times a b will give us the b squared. So far, so good. Think of two factors of 14 that would add up to 9, since this is a positive 14. Well, 7 and 2 add up to 9, and they're factors of 14, so a positive 7 and a positive 2. b times b squared. Distribute this all out, you would get a 2b, a 7b, which makes our 9b, and 7 times 2 makes the 14. So you should be getting to a point where these are simple, at least when they have a coefficient of 1. Our next two examples have coefficients of 1, so let's look at those. We have the a squared plus 5a minus 24. So again, open up our parentheses, a and a. We have a negative product, so our factors of 24 have to have a difference of 5. 8 and 3 multiply out to 24 and have a difference of 5. We want a positive 5, so the 8 should be the positive number in this case, so we can write a positive 8 and a negative 3. A plus 8, a minus 3 would be the factored form of a squared plus 5a minus 24. Excuse me. Moving on to number 6, we've got the p squared minus 9p plus 18. Excuse my handwriting. Open up our parentheses. Again, so let's think. Since this is a leading coefficient of 1, p times p gives us p squared. Now, it was p squared minus 9p plus 18. Plus 18 means that we're going to have two positive numbers or two negative numbers. In this case, since we have a negative middle term, we're going to want two negative numbers. So we'll need two factors of 18 that add up to 9. In this case, 6 and 3 add up to 9, but they both need to be negative, so a p minus 6 and a p minus 3 will work in this case. So p squared minus 9p plus 18 factors out into p minus 6 times p minus 3. Okay. Finally, we've arrived at a different kind of problem. No longer are we just looking at a leading coefficient of 1. In this case, we only have two terms. Now, if you think back to what we've been working on, you should recognize this as a difference of squares. X squared is x times x, 4 is 2 times 2, and 49 is 7 times 7. So all of these are squared terms. So the square root of 4x squared would be 2x. So we've got the 2x times the 2x. Since the 4x squared is a positive, 2x positive appears twice. We've got the 49, so then 7, 7, and then we can just fill in our signs, a minus 7 and a plus 7. And the factored form of 4x squared minus 49 is 2x minus 7 times 2x plus 7, a difference of squares. Finally, we'll look at number 8. In this case, you finally have a coefficient that is not equal to 1. So, this one you might be able to factor mentally, but it's always great just to use your sums and products method, because that one will guarantee you'll either find out that your expression is prime, or it eliminates a lot of the guesswork. So, in this case, our sum, our ST, will be the negative 5k. So our MT, our multiplies 2, would be 2k squared times negative 12, which makes a negative 24k squared. So we'll want to think of factors of negative 24 that add up to negative 5. In this case, since it's a negative product, they would need to have a difference of 5. Again, if we go back to one of our previous examples, number 5, 24 and 5, 8 and 3 have a difference of 5, and we want a negative 5, so in this case we'll want a negative 8k and a positive 3k to fill in our box. So we can go ahead go to our box, fill in what we had. We had the 2k squared, and then the negative 12. We can fill in the 3k, and then the negative 8k. So we've got k times k makes that k squared, but we need to think of where our 2 is going to go. So over here, if you notice, we can factor out not only the k at both of these, but also a 2. 2 goes into 2, and it goes into 8. We've got the 2k here. 2k times k gives us our 2k squared. Now we need to think of what times 2k will multiply to negative 8k. In this case, a negative 4 will suffice. Then we've got k. What times k will give us 3k, in this case the positive 3, and just to make sure, we've got a positive 3 times a negative 4 makes our negative 12. So we've got 2k plus 3, and k minus 4 as the factored form of 2k squared minus 5k minus 12. So just to recap, all of our coefficients of 1 should be to the point, anytime we see a quadratic trinomial, 3 terms, degree of 2, with a leading coefficient of 1, normally you'll just be able to do these mentally now. Anytime we see something that's not equal to 1, go ahead and try your sums and products method. This will guarantee you the correct factorization if you do it correctly, or it'll show you if the expression is prime. And of course, we still have our difference of squares and many other special cases that we can recognize. So now that we've kind of worked with factoring, and we've been working with factoring, let's start looking at some applications of factoring. Well, we can look at problem 9, where it says the area of a rectangle is represented by 3x squared minus 7x minus 6. It wants you to find the length and width of the rectangle. Okay, so if the area is equal to 3x squared minus 7x minus 6, area of a rectangle is given by length times width. So we want to think of two quantities that we multiply to get 3x squared minus 7x minus 6. In this case, when we factor, we split our expression, but we factor an expression into its factors that will multiply out. So we'll want to factor this expression in order to get our length and width. So again, we don't have a leading coefficient of 1, so we're going to use our sums and products method. So we've got st in this case would be negative 7x. Our mt would be negative 18x squared. So we can fill in our box with what terms we have. We've got the 3x squared and the negative 6. I can think for negative 18 squared, 9 and 2 have a difference of 7, so a negative 9x and a positive 2x. So we'll fill these in, the negative 9x and the positive 2x. If you can see, I multiply these, I'll get this. If I add these, I'll get negative 7x. So let's think. We've got the x times x makes the x squared. Notice the greatest common factor along here would be a 3, so we can make the 3x here. 3x times x makes 3x squared. 3x times a negative 3 makes our negative 9x. And then x times a positive 2 makes our 2x. So 2 times negative 3 makes the negative 6. So the length and the width can be represented by 3x plus 2 and x minus 3. If you multiply these out, this length and this width, you get the original area you started off with. So this kind of is a connection maybe to our algebra tiles. This could have been represented with algebra tiles. You would have filled them in, and then this would have been the corresponding length and width, along the side and the top. And if you multiply those out, you'd get your area. Number 10 says the area of a square is represented by 4x squared plus 12x plus 9. What is the length of each side of the square? So notice it says the area of a square. So if we can think back to our square formula, the area of a square is given as side times side, or side squared. So let's see if we end up with two factors that are equal to each other. So again, we'll fill in our box with what we know. We've got the 4x squared and the 9. Let's think 9 times 4 is 36, so that's our MT, 36x squared, and then our ST would be, 12x. So let's think of, I say, 36x squared, so 6 and 6. We've got the 6x and the 6x, because 6x times 6x gives us 36x squared and adds up to 12x. So let's think, greatest common factor along here would be a 2x, and then 2x times 2x makes the 4x squared, 2x times 3 makes that 6x, and then 2x times 3 makes that 6x. Notice, this is a square, because the two expressions, the two factors of 4x squared plus 12x plus 9 are equal to each other. So the factored form could be given as 2x plus 3 times 2x plus 3, or if you want to condense it, we can write it as 2x plus 3 quantity squared, since this is a square. And let's look at number 11. Number 11 says, the area of a rectangular lot is represented by 14x squared minus 9x minus 40. If the width is 7x plus 8, what is its length? Okay, so we again have that the area is equal to length times width. So let's kind of fill in what we know. It gave us one of our factors. So let's work with just the 14x squared for now, and the negative 40. And you'll see that we don't necessarily need our middle terms if we're given one of our factors. We've got the 14x squared and the negative 40. Let's say we've got the 7x and the plus 8, because that's one of the factors it gave us. It gave us the width. Now we just want the length. Well, what times 7x would give us 14x squared? Well, in this case, that would be a 2x. And then what times positive 8 would give us the negative 40? That would be the negative 5. And you could fill in your box if you wanted to, and you'd see that you would get, you'd get the negative 35x and the 16x. 35 minus 16 is negative 9. Well, negative 35 plus 16 is the negative 19, so we have our original product. So the length, since we were given the width, would be 2x minus 5. The width was 7x plus 8. That's where we got our length. And then finally, let's look at number 12. Number 12 says a rectangle has a length of 4x plus 3 and a width of 5x minus 2. What would be the expression that represents the area of this rectangle? So if we have a length and a width, and we want the area, we need to multiply that length and width. So we can multiply 4x plus 3 times 5x minus 2. I'll go ahead and work this both ways with distribution and the box, which the box is just an organized way of distributing. 4x times 5x makes the 20x squared. 4x times a negative 2 makes a negative 8x. 3 times 5x makes a 15x. And then 3 times negative 2 makes negative 6. If you combine your like terms, you'd get 20x squared plus 7x minus 6. And I'll go ahead and work this in a grid as well. We've got a 2x2 box, since we've got a binomial, two terms, times a binomial. And excuse the size of my boxes. We've got 4x plus 3, and then 5x minus 2, again the 20x squared, the negative 8x, the positive 15x, and then the negative 6. We've got our like terms, so we again have the 20x squared, negative 8x plus 15x, or 15x minus 8x makes the positive 7x, and then we've got our lone negative 6. Same thing. So again, box method is just an organized method of distribution. So now we've combined our factoring techniques, applied them to area, and learned that we can do some of them mentally now. Of course, sums and product is always a great way to check yourself. But here's some applications. Hopefully you understand factoring a little better now.